Hey everybody, welcome back for another video in our basic networking series. In this video we're going to be covering something called router on a stick. If you remember in our last video we covered VLANs. We saw that with VLANs we can separate networks and logically divide traffic going through our switch. But we also saw that those VLANs were not able to communicate with each other by default. So this is our solution to that, or one of the solutions that you can use for that. It's called router on a stick. So like I said, in order to communicate across different VLANs, a router is required. Router on a stick means using one router with sub-interfaces to route traffic between VLANs. Each sub-interface is going to need an IP address that's within the same network as the intended VLAN. Some new commands that we'll be going through today are the sub-interface command, which goes interface, your interface, dot, your VLAN number. That'll create the sub-interface for the VLAN number that you've specified. Then once we're in that sub-interface, we're going to issue the following command, encapsulation.1q followed by the VLAN number. This is going to configure that sub-interface for packets tagged with the VLAN number. After we've done that, we can give that interface an IP address that's in the correct network for the VLAN, and we should be good to go. So without further ado, let's hop down here into our lab. We see the purpose is to configure a router on a stick to communicate between VLANs. In our diagram, it looks like we've got VLAN 10 over here on the left in this 10.10.10.0 network. And on the right, we have VLAN 20 in the 20.20.20.0 network. And it looks like we'll be using the addresses 10.10.10.1 and 20.20.20.1 on the sub-interfaces that we build in the router to route between these VLANs. So let's hop over here into the tasks. Step 1 says review the current VLAN configuration on the switch. Okay, so if we hop into the switch, we go ahead and hop into the command line interface, go enable. From here, we can issue our show VLAN brief command. If I expand this to make it look prettier. So here we can see we have VLAN 10 named left and VLAN 20 named right. We got port 1 and 2 in VLAN 10, and we got port 3 and 4 in VLAN 20. Okay, perfect. Now we know that for us to be able to send more than one VLAN across a link, it needs to be a trunk. So let's see if we have a trunk going across this port right here. So let's do show interface trunk. We do. It says port 5 is a trunk, native VLAN 100, allowed VLANs 10 and 20. So it looks like the switch is already correctly configured to handle our two VLANs. So if we move on to our next task, it says verify that only devices within the same VLAN can communicate. So we hop into a PC over here, into its desktop, into the command prompt. We issue the ping command. Let's ping its neighbor 10.10.10.4. And as suspected, we can talk to him. Now let's try and ping somebody in VLAN 20, like 20.20.20.3. Go ahead and hit this speed up button. See the results of that. And as suspected, we cannot communicate with him because he's in a different VLAN. Okay, looking good so far. Step 3. Configure sub-interfaces on the router to support each VLAN. So if we hop into the router, we're going to go ahead, enable configure terminal. Now what we want to do is we want to hop into the sub-interfaces right here on this router. First, we're going to want to look and see which interface we're using. Let's do a do show IP interface brief just to double check. Looks like G000 is the interface that's up and connected right now. So what we're going to do to hop into the sub interface, we're going to go interface G000 dot. We'll go ahead and do the sub interface for VLAN 10. So we'll do dot 10. Enter. Now we're in the sub interface, as you can see by the prompt. We're going to go ahead and issue encapsulation dot 1q and then the VLAN number, which is 10. Enter. Now we can give it an IP address for that network, so we'll go IP add 10.10.10.1. with 255.255.255.0 as a subnet mask. And that should be all we need for that interface. Let's go ahead and hop into interface G000.20 for VLAN 20. Go ahead and issue encapsulation .1Q 20 for VLAN 20, and then we can give it an IP address for that VLAN of 20. IP address 20.20.20.1 255.255.255.0. Enter. Perfect. So that should have correctly configured those two sub interfaces to handle VLAN 10 and VLAN 20. Let's move on to the next step. It says verify the interface configurations on the router and that each of the VLAN networks can be seen. Okay, we hop back in here, back down to privileged exec mode. We can go ahead and go show IP interface brief. Now we see, apart from our G00 interface, we have G00.10 and G00.20 right here. They both have IP addresses and they're both in the up. Next command, we can do show IP route. And here we can indeed see network 10.10.10.0 and network 20.20.20.0, so that looks correct. Let's hop into our final step, which says verify that the two VLANs can now communicate with each other. So we hop back into that PC3 or PC1. Go ahead and now try to ping 20.20.20.3. Our first request usually fails in packet tracer, that's normal, but after that you can see we can communicate with the other VLAN. So we have successfully implemented router on a stick. We've created these two sub interfaces here. We've marked them with the appropriate VLAN numbers, and we've allowed our two VLANs to be routed together to be able to communicate with each other. So I hope that you were able to follow along with this lab. If you haven't already, go to the link in the video description below and download all the labs so that you can do them in the future on your own. And I hope that we'll see you in the next video where we get into more interesting content. See you next time.